This is the third video in the FTC programming course, and in this part we're going to look at the bigger picture and talk about software design. Alright, so we're going to be designing the code for a theoretical robot that plays the game Into the Deep, which is the 2024 game, if you're watching this in the distant future. So the robot has 3 subsystems. So the first is a drive base with 4 mechanism wheels. The second one is an arm that can rotate using a motor, and it can extend using a motor. And then the third subsystem is a claw that can swivel up and down and also open and close using 2 servos. To plan out the structure of our code, we'll make something called a class diagram. I'm making one on draw.io because I have bad handwriting, but you could obviously do this on a whiteboard or on paper for your own robot. The point of a class diagram is to map out all the different classes that we have in our project and the relationships between them. So, for example, we might have a fruit class and then 2 different classes that extend it. And under each class, you can see they have different methods and attributes that are listed. So attributes are listed with their name, and then a colon, and then their type. And then methods are listed in the same way with their arguments or their parameters in parentheses. And then hashtag will indicate protected, a plus is a public, and a minus is private. In general, especially in FTC, it's best to program from top down. What this means is you plan out the general shell of your code before you actually start implementing any code. And the advantage of this is if you jump right into coding without planning, you might want to make a big change. And that means you would have wasted a lot of time coding, because coding takes a lot longer than planning code. Let's start planning out the classes for our robot. So I've started by making our teleop mode, and we're gonna ignore auton for now, but as you can see, it's extending the linear op mode, which is part of the FTC SDK, and I listed some of the functions that we used in the last video. So as you can see, we had a run op mode, we used wait for start, we used op mode as active, and our teleop class is extending linear op mode. You usually want to divide your robot into a few subsystems. So like I showed you at the start of the video, I divided the robot into a drive base, an arm, and a claw. And that's 3 different subsystems which can each have their own class. So let's make the arm class. We'll start by thinking about the arm class as a black box and only focus on the public methods. So what I mean by this is we're only going to think about how other classes interact with it as opposed to its inner workings. The arm has 2 moving parts. It's the shoulder and the actuator, if you remember from the start of the video. So let's think about what public methods would be useful to interact with the shoulder. So I want the shoulder to be continuous rotation controlled. So I want to have a method called move shoulder that will just set the speed of the shoulder motor. That's all. So just double for speed, which is the parameter, and returns nothing. So this is one of the methods where another class can just set the speed of the shoulder. And what about the actuator? I want the actuator to be position controlled, meaning other classes can give it a position and it will automatically move to that position. So I'll call it set actuator pose with a double that is a position. That is a position. And if you think about another class trying to call this method, other classes might have no idea about, well, what kind of numbers are down. They have no idea about the scale. So what number is down, what number is up, what number is the middle. So something we can do to help with that is have a public attribute on the arm so that the arm can actually tell other classes what its down position is, what its up position is, what its middle position is. So let's just have an attribute called actuator up position. This is going to be a constant with a double, so other classes can see what's the up position, and we'll have the same thing for down. I think that's enough. And we also want to keep moving the position of the actuator based on its target position, right? Because unlike the shoulder, we're controlling the target position of the actuator as opposed to its current motor speed. So we want to have a method that gets called basically every frame of the program so that the arm class can update the speed of its actuator motor. So let's do one more method. So let's call it tick actuator. So to clarify, this method is going to be called every frame no matter what by the up mode, so that the arm inside of it, this method, can update the position of its actuator motor. Okay, now we know how other classes interact with the arm class, so we can start thinking about how it works within itself. And that means we're going to start thinking about private attributes and methods. And the first thing that comes to mind to me is it needs to have two motors. So it might have a shoulder motor, which is of type motor. So this is just an attribute, which is an instance of the motor class. And it will also have an actuator motor. Which is also an instance of the motor class, and it's private. And the reason these are private is because, well, other classes don't need to access them. The arm is the only class that needs to know about these two motors. And I can't think of any other private attributes that this class needs, so let's move on. And remember that since this is just a diagram, I can easily go back and change this later. We'll do the same thing for the claw subsystem. So I want both servos in the claw. So that's the servo that moves the wrist up and down, and the servo that opens and closes the claw to be position controlled. So I'll just have two public methods. Maybe set wrist position with a double and void, and then set claw position with the same thing. And let's add some attributes so other classes have some reference points. So for the wrist, we can have maybe wrist intake position. So when we're picking up a block, we'll have that be a double. And maybe wrist outtake position. So when we're dumping a block into the basket, or a sample into the basket. And then for our claw, let's just have a closed position. Claw, closed position. And also an open position. And for the private properties, we can just do a wrist servo, which is a servo, and then claw servo. Which is also a servo. And that is the claw class planned out. For the drive-based subsystem, we'll use one of FTC lib's classes. So it's the mechanism drive class, and it's very useful. It'll save us a lot of annoying math because all we have to do is give it the 4 motors when we initialize it, and then every frame we call one of these 2 methods and give it the joystick X and Y positions, and it just does all the math for you. So it has one that drives based on the robot's perspective and one that drives based on the player's perspective. So it's nice to have 2 different options. And now we can give our teleop class a copy of each of the subsystems, or an instance of each of the subsystems. So as you can see, I give it 3 private attributes, one with an arm, one with a claw, and one with a mechanism drive. And in our class diagram, we can actually symbolize this too by having one of these arrows. And this shows a has a relationship. So the teleop has an arm. And the teleop also has a claw. So that's what this arrow means. The teleop class has a mechanism drive with them. You get the idea. And this number 1 over here represents that the teleop has 1 of this, and 1 of this, and 1 of this. And this is our completed class diagram. So in future videos, what we're probably going to do for the rest of the course is just implement each of these classes, so you really get the feel for making an entire robot program. Bye-bye.